Okay, yesterday we talked about parabolas that are in standard form. Today we talk about parabolas that are in vertex form. And again, we specifically want to look at the extreme values of these. And when you graph a parabola that's in vertex form, it's called vertex form because this is the vertex, and we can tell the location of the vertex. You're going to start off right on the front page. We're going to tell the vertex by simply looking at the transformations. For example, what is the horizontal transformation? If I were to write it as, say, y equals 2 times x minus 5 quantity squared plus 3, what's the horizontal shift? 5. What is the vertical shift? 3. So therefore, the vertex in that form is just hk. You know, this represents your horizontal shift. That represents your vertical shift. That tells you your vertex. That's it. So if you flip forward 2 pages to this, you can see graphing parabolas that are in vertex form. HK does tell you the vertex. The value of A being positive or negative still tells you whether or not it's up or down. The axis of symmetry still happens to be x equals the x value of your vertex. The y-intercept, we'll talk about that in a second, but really the key today is to be able to take these equations and put them into vertex form. So right now, as you look at, so back up 1 page, as we look to example 2, it says a quadratic function is given, express it in vertex form, sketch its graph. We're going to name some important spots on that graph, but then we're going to talk about a maximum or minimum. Right now, it's in standard form. The skill I'm going to teach you now is new to many of you. You're going to have to do this skill on the test. And then you're going to have to do it quite often when we get to chapter 9. You want to ensure your ability to do this part-time. To be able to do this skill. Please follow along very closely. All 3 examples are unique and important. As soon as you have a question, stop me and ask. We have y is equal to a times x minus h quantity squared plus k. It is currently in standard form. We would like to place it into vertex form. Now, obviously, you could do negative b divided by 2a, and that would find the vertex. Here's another option. Let's complete a square. I'm going to write the 1 over to the side. And I'm going to turn this portion into a completed square. What number would I add to complete the square? How do we get 9? Divide by 2 and square it, I get 9. Now, all my math teachers over the years have said that if you add something to one side, you must. So I go and add it to the other, but before you write that, just consider our final answer will not be 9 plus f of x. Our final answer will be just f of x equals, correct? Eventually, what will we have to do with that 9? Eventually, we'll just subtract it over. So I'd like to teach you kind of a new thought. And, this might not be comfortable to you, but you need to become comfortable with it, okay? I'm eventually going to subtract it over anyway, right? So I've added 9 to that side, and I've subtracted 9 to that side. What is the net change? 0, right? I mean, there's really absolutely no difference in the equation as the same form that it did before. We've just played a little trick. And the reason why we play that trick is so that we can say f of x is then equal to, what does this factor down to? And then I have a positive 1 and a negative 9, which makes negative 8. So now I have a parabola that's in vertex form. I know the direction. What's the direction? And I know the vertex. What's the vertex? 3, negative 8. So no need to do negative b divided by 2a. We simply completed the square. Okay. I look at the axis of symmetry. And it's always x equals the x value of the vertex. The y-intercept occurs at, look at the original function. Suppose we didn't have the original function. The y-intercept happens when x is equal to 0. So if you were to plug 0 in for x, 0 minus 3 is negative 3. Squared is 9. Minus 8 is 1. Okay, so you can see that you still come up with that. Everybody okay there? Let's sketch the graph. Remember, if you have a question, please ask it. Chances are, if you have the question, at least 5 other people in the class do as well. Okay. X-intercepts, very good point. Okay. So we're not going to find the x-intercepts here, only because we really don't often have an application for it with these type of problems. Now, way to address your question, which is really good, if you want to find the x-intercepts, that's when the y value is equal to 0, right? And the thing is, we've dealt with that many times. In order to solve that, it's already a completed square. We add over the 8. We square root both sides. And you add the 3. Right? So I'm trusting everybody would be able to do that. But we will not make you do that for this lesson. Though it is good to keep in mind that you are able to do it. Okay? All right. So I plot the points. I've got 3, negative 8. Got an axis of symmetry of a y-intercept of 1. Yeah. So does that parabola have a minimum value or a maximum value? It has a minimum value of what? Negative 8. Yep. And we'll say that it occurs at 3, but the minimum value will actually say is a y value. Minimum of negative 8. We all good? Yep. So you can take that point if you really wanted to. I just kind of eyeballed it, but you can take that and reflect that over, okay, that line, and I'll create a third point for you, and then you get 3 points. I will not be that critical with your graph when you're putting it into vertex form. What I want to see when you have vertex form is that you have the vertex correct, the shape correct, and then the axis symmetry. Okay, let's flip it over. Let's look at a different example that has just a slight variation. What's different about this example? Yeah, and if you notice, when I have y is equal to a times x minus h pi squared plus k, first of all, you can see that there's no y-intercept here. The y-intercept is 0. But also, you can see that I have something factored out in front of it. So you're always going to list it as a positive x on the inside. Okay, you're always going to list it as a positive x. So what do I need to factor out? A negative. So therefore, I have f of x is equal to negative quantity x squared minus 4x. Take out the x as well? Yes, you could. However, if we want to have a completed square, we need this to be a square. So, what do you add to complete the square? 4. So what would you add to the other side? You would add 4 to the other side, so subtract 4. But before you do that, everybody pause. Okay? The true value of this x squared, is this x squared positive or is it negative? It's negative, right? Is this 4x positive or negative? It's positive. Is this 4 positive or negative? It is negative. So we did not add 4 to both sides. We subtracted 4. So therefore, we will add 4 to that same side. Now, if you are not convinced by that, convince yourself. if I were to distribute the negative through, I would get a negative x squared plus 4x minus 4 plus 4. Those would go away, and I would have the same expression as above, right? But if you left that as a, or if you put a negative 4 back here, you would not. You would have a minus 8 on the end, wouldn't you? Okay. So that's why you got to reconcile that in your mind. But I think this is by far and away the most efficient way to do these types of problems. So we have f of x is equal to negative quantity what? Y squared. Good. Direction. Vertex. No, not a dumb question. You can look at the original, or you could look at what you currently have. If there's a negative out front, it will go down. 2, 4. Axis of symmetry. X equals 2. The x value of the vertex. And remember, you may not simply just write 2. It's not a point. Okay? The y-intercept. 0. Make my graph. A little snow outside, huh? I plot 2, 4. I'm going to make Gigi's point, which was that you can see that this sits 2 units away from the axis of symmetry. So therefore, if I reflect it, I do have another point over there. I go ahead and make my shape. Does this have a min or a max? Very good. We're on the ball today. Lots of answers being shared. Very good work. I will stop. Thank you for asking. Yep. Okay, the third example, and the most complicated because it challenges your number sense. Your number sense. I can't have a 2 in front, so therefore, factor out a 2. And I get x squared minus 3 halves x. I'm going to leave the 1 on the outside of the parentheses. If you're not convinced that those are the same, distribute the 2. You'll come up with the same thing we have up above. I don't want to deal with the 1. I'm going to leave that space so I can complete my square. Let's complete the square. 3 halves divided by 2. Multiply by the reciprocal and you get 3/4. So 3/4, 3/4 squared, 9/16. That's not really 9/16. What? It's 2 times 9/16. Right? We have 2 times 9/16, which is 18/16 or 9/8, right? Very good. So I have a plus 9/8. So if I added 9/8, I should subtract 9/8. Good. Good work. Yeah. 2 times good, x minus 3/4. And then negative 1 is like negative 8 over 8. So negative 8 over 8 minus 9 over 8 would make the negative 1. I'm going to make as a yes. But 2 times 9/16 is going to give me the true value of it. Just like up above, we said that's not really a 4, it's a negative 4. Same thing here. That's not really a 9/16, it's a 9/8 because I multiplied by the 2. Okay. All right, so we've got that. Direction is up. A vertex. Good. Negative 17 over 8. That is approximately what value? Yep, negative 2. So if I make a 2 by 2 graph here, that should be sufficient. Maybe even a 3 by 3 so I can reflect a point. So 3/4 and negative 17 over 8, or 3/4 and about negative 2, a little bit more than that. Axis symmetry goes right between them. Y-intercept of negative 1. Want to reflect a point over, that would go over to 1.5. We have our shape. Min or max? Minimum of negative 17/8. So I've prepared a worksheet for you today, and in addition to that worksheet, previous years, I've asked them to do 2 word problems for application. I would make an exchange with you. If we do the 2 word problems in class, we just won't do them on your assignment. How's that? So let's look through these. Anybody taking physics right now? Okay, nobody's taking physics. All right. Ball is launched directly in the air with initial velocity. We're not going to do 100, we're going to do 40. Initial velocity 40 feet per second, okay? So I take an object, it's tossed into the air. Okay, what shape would that make as it's tossed into the air? An arc. It would make a parabola. You can see that the height is modeled by that equation. So we have this shape. That's the first thing to recognize. It then says, what is the maximum height of the ball? So does the shape have a maximum? Where does the maximum occur? At the vertex. How do I find the vertex? Well, we were just doing. Or you could do negative b divided by 2a. Here's where you recognize the errors because of free country. You get to make your own choices. I choose negative b divided by 2a. So negative b would be negative 40 divided by 2a, negative 32. Both those are divisible by negative 8, so I get 5/4 or 1.25. You think that that's the time value or the height value? Time. If you think about it, a vertex has an x value and a y value. Look at our equation. It has t where the x is, t for time. It has h where the y value is, h for height. It's going to be important that we keep those descriptors in our minds as we move on to the next unit, as we do encounter a lot of word problems. So we got 1.25. How will I then find the height? Plug it back in. It's a very good. Thank you, commercial. So, have you guys actually seen those commercials? I didn't know that they were still like. So like, how about the I've fallen but I can't get up? Like, right, but they just reintroduced one. Like they were on like 15 years ago, and then all of a sudden like they started playing again. I'm like, wow, okay. Yeah, people find. Nano, you're horrible. Wow. We had a 20-year period where nobody was falling. Yeah, and then all of a sudden they started falling. All right. So max height of 25 feet at a time of 1.25 seconds. The question was, what's the maximum height of the ball and what time does it attain that height? I believe I've answered the question. Well, thank you. Yes, I'm very proud. What's that? Did she speak Spanish there? Yo soy muy guapo. I can choose to yell if I want. All right, last example. So we have a food price. So the question is, the price index is given by this function. Does this look like a parabola? No, because it's third degree. We don't know what this looks like. But it's wondering, when was the food most expensive? Well, I need to find a maximum. So let's go into y equals and let's type that in. You don't have to type it in. You can watch me do it. Negative 0.0113 t cubed plus 0.0681 t squared plus 0.198 t plus 99.1 Zoom standard. And here is my graph. What do you think? Why can't I see the graph? Very good. Y-intercept of 99.1. So therefore, I'll change my window, and I'll make my minimum, say, 99. Make my maximum, say, 102. And maybe I can see the graph now. All right, I can see it. Is there a maximum that happens over the interval 0 to 10? Is there a maximum that happens? How do I find that? So I can calculate number 4. And I go over to that maximum location. And then it's going to ask me to move to the left. Once I arrive there, I move to the left. Once I'm convinced that I'm to the left, I can then move to the right. And once I'm convinced I'm to the right of that, I can press enter, enter on guess, and I get x is equal to 5.15. So look at the question, though. It says, when was the food most expensive? 5.15? That doesn't make any sense. So we got t is equal to 5.15. And it's saying that 1990 is the year 0. Then what is the year 5.15? That's really the year. Yeah, 1995 would be the year when the price was most expensive. And it says mid-year, so that would be like June, right? So 5.15, that might be like, say, July of 1995, to be specific. Oh, you okay, buddy? Okay, all right. Well, it says mid-year. Mid-year. Okay. All right. You have a worksheet.